Let's do another exercise on this. Just imagine that we have a mass here hanging with two ropes, and these two ropes made angles of 60 degrees and 30 degrees. We know that the weight of this object is 8 newtons, and we want to know what are the tensions that the two ropes are going to sustain. So in order to do that, we will apply Newton's second law, and we will know, first of all, we need to know that that's an equilibrium, that there is no acceleration. So if there is no acceleration, the net force has to be 0. But look that we have forces in different directions and having different angles, so we have forces in 2D in this case. So we need to apply Newton's second law in the x-axis and then in the y-axis. And because this is equilibrium, the net force in the x-axis and the net force in the y-axis, both of them have to be 0. So let's go. First of all, we define the axis. This will be the x-axis, this will be the y-axis, and I know that the sum of fxi has to be equal to 0, and the sum of all of the forces in the y-axis has to be equal to 0. Okay, before starting, first step always, draw the free body diagram. So we have first force, the weight of this mass, and then we have tension 1 and tension 2. So we have 3 forces, and the net force, the sum of these 3 forces has to be equal to 0. So what I suggest to do is to project all the forces into the x-axis and the y-axis. This weight is already in the y-axis, but these two have components in the x-axis and in the y-axis. Let me redraw it here just for the sake of clarity. And let's pay attention to these angles. If this angle is 30 degrees, you know that if you have two parallel lines, then this angle alpha has to be the same as this angle alpha. So if this angle is 30 degrees, this angle is 30 degrees. So this is 30 degrees. And with the same reasoning, if this angle is 60 degrees, this angle is 60 degrees, and that angle is 60 degrees. So now let's project first x-axis. We have this projection here, so this will be T1 times cosine of 30 degrees, positive, and then negative we have minus T2 cosine 60 degrees, and that has to be equal to 0. So that is just Newton's second law applied in the x-axis. Let's talk about the y-axis. We have negative w, and these two are positive, so we have T1 times sine of 30 plus T2 sine of 60. And that, again, has to be equal to 0. Now we have two equations with two unknowns. Our only unknowns are T1 and T2, but we know W, which is 8 newtons here, and we know the sine of 30 and 60, so it's a system of two equations with two unknowns. So we can just solve for T1 here and substitute on the other one, and then solve for T2, and once we have T2, we'll go back and get T1. Yeah, let me do it. From the first equation, this is T2 cosine of 60 divided by sine of 30. And once we have this, if we substitute in this other one, minus W plus all of this, T2 cosine 60 divided by sine 30. This is just T1, now multiplied by sine of 30, plus T2 sine of 60, and that is equal to 0. you solve for T2 here, and then you substitute here. I will just give you the results. T2 is 6.9 newtons, and T1 is 4.0 newtons. So I led you to get to these numbers from those equations. And that's basically how we're going to be solving this type of problems. First step, free body diagram. It could be 3 forces, it could be 27 forces, but first of all, always the free body diagram. Second step, we decompose into all the axes. In this case, it was just x and y. We could have had x, y, and z. Just decompose into all the axes and then apply Newton's second law. Net force is equal to mass times acceleration. If the system is in equilibrium, acceleration is 0, things get a bit simpler.